Hey, good morning. This is Dr. David A. Padgett. Today is January 28th, 2021, 9:35 a.m. And this is World Regional Geography, this is Weather and Climate, Geography 3500. This is also an honors class, honors 3012. And so today we are going to follow up where we started off on Monday. And so I'm going to share my screen now, and we're going to get into the course landing page. And so here it is. Again, this is an asynchronous format class, which means that we don't have a set meeting time. In general, we'll meet from 9:35 to 11 a.m. Central Time on Tuesdays and Thursdays. That time might move around based upon my schedule. But in any case, all lectures will be recorded. And so that allows for students to watch the lectures when it is most convenient for you all. The lecture recordings will be posted as soon as possible after class. And so here is the first lecture recording is here. Let me get into student mode here. All right, so this is student mode. Okay, so the first lecture recording from Tuesday is here. The January 26th recording. This one will be posted as soon as possible after this class. So in terms of navigating the class, when you arrive at the landing page, the best thing to do is just to scroll down to the calendar. Among other things, you should read or should have read the course syllabus. If you need a review of that, I talked a little bit about the course syllabus on Tuesday, and so that's part of the recorded lecture. So let's jump right into things here. We're starting off this week going right into a hands-on outdoor weather observations exercise that is due at 9 a.m. on Saturday, and that's for a reason. Okay, so here is the exercise, and here are the various components of the exercise. And so I went over this in detail, but just to walk through it again, here is the assignment in the Word document. And so this assignment gets us right into familiarizing ourselves with atmospheric data. And so you will do this exercise outside wherever you happen to be, even if you're not in Nashville. I know a lot of people are not in Nashville for obvious reasons. And so this is an exercise that can be or will be completed remotely. And so we're going to be working a lot this semester or times this semester with the Global Learning and Observation to Benefit the Environment program. And so take you to the GLOBE page. And so again, GLOBE is a federally sponsored and funded program that has as its main goal improving science education at the K through 12 level. Now, the data that are collected by students and citizen scientists all over the world are actually used to support publishable scientific research conducted by NASA scientists. So that's why the data collection is done according to specific scientific protocols, so that every person that adds GLOBE data to the GLOBE site collects those data theoretically at the same time and with the same methodology every day. So that way the data will be scientifically valid. And so, for instance, what you'll be doing is getting some atmosphere data. And so let me just visualize the data. So anytime anybody collects data, the way that you're going to collect data, it shows up here on the globe data visualization system map. Let's see. So here is, so it looks like someone in Georgia at the school in outside of Atlanta, Holy Innocents Episcopal School, collected some air temperature data today, and we can visualize those data here on this graph. So let's see, we're looking in degrees Celsius, and so we have 3.8 degrees Celsius. Actually, this is on, the 28th of January. And so when you collect your data, then it'll show up on this map, or when anybody does. So in order to do this properly, you have to do some preparations. And so the first thing that you'll do is get the Globe Observer app on your mobile device. And so it's a pretty neat application. It's a free app, the Globe Observer app. And you'll simply, so let's say this is your mobile device. And then when you get the Globe Observer app, it'll look something like this when you open it up. It's very simple. Be sure to do this before you go outside. This is part of your prep because you really don't want to be outside using this app for the first time, because for obvious reasons, you want to be prepared before you go outside. Okay, so you'll be making a cloud observation using this app. And so as you can see, along with the assignment itself, we go back into the assignment. You have a variety of attachments, and one of them is how do I get out of student mode? Okay, so I'm back into student mode. I was in developer mode. Okay, so when you go in here, you'll notice you have a variety of forms and et cetera, et cetera. And so one of the things that you should look at, of course, are the instructions, but you need to download. You can either download and print the Globe cloud chart, or you can download the JPEG. So if you download the JPEG of the Globe cloud chart, you can actually put this Globe cloud chart onto your mobile device, so that when you're out, while you're outside, you can actually make your cloud observations using the chart. So when I scroll down to the directions, notice that, after you get outside, you'll do two things. You'll make a globe observation using your naked eye first. And so if you go back to the first recorded lecture, you'll see that I went through in detail how to use this cloud chart to make an observation. And again, if you add the cloud chart to your photos in a JPEG format like this. Then you've got the cloud chart on your phone while you're outside. And so you don't have to print it out and bleed out your ink on your printer. And so you go outside and just walk through the um, what you need to see in the on the cloud chart observation sheet, as I pointed out on um, Tuesday. Let's see here. Open that up again. And so here is the cloud chart again. And so you just go outside and you can either make note of what's here, and then if you you can either fill out this sheet in the PDF. So there is a PDF and you can print that out, or you can actually open this file up in Paint. Go into the Paint program here, and then open the file up in Paint. So here it is in Paint, and then you can use various tools to fill it out in Paint. Of course, I need to change the font from 48 to something much smaller. All right, so you can use the Paint program to fill out the chart if you like so. Probably will be much easier to do if you just fill it out with a pen or a pencil and take a picture of it, as is noted in the instructions. But if you don't have the option of printing, then there are some workarounds so that you can fill the sheet out. But again, when you go outside, and you walk through the instructions on the sheet, this is much better. You're just making a cloud observation. Look up in the sky. Try to pick a day when there are ample clouds in the sky. This time of year, we get a lot of high pressure systems. I noted on that map of that temperature observation in Atlanta. It was 3.8 degrees, Celsius, which is it's fairly chilly. If you consider that 10 degrees Celsius is about 50 degrees Fahrenheit. So pretty chilly morning. 0 degrees Fahrenheit is, 0 degrees Celsius is about 32 degrees Fahrenheit. So you can imagine that it was a pretty chilly morning in Atlanta. Probably high pressure system coming through. And so high pressure often, when a high pressure air mass influences a region, that is when we often see a cloudless sky. Clouds are usually associated with, or oftentimes associated with, low pressure systems because air is rising. And as that air rises, it it cools to its dew point temperature, condensation takes place, we start to see clouds. When there's high pressure, air is sinking, and so therefore there's more stability in the atmosphere. We don't see clouds. And so this time of year, one characteristic of high pressure air masses is they tend to be cold. Cold air is more dense than warm air, tends to sink. And so that's when we have these cloudless days. I don't think there are a whole lot of clouds outside here in Nashville today. So that's the first thing that you'll do is go out and make this cloud observation using your naked eye. If you need any assistance with the observation, even while you're outside, again, my phone number is right here, 615-258-3657. That number is this number. So this is not my personal phone. This is a TSU. It's not TSU's phone, but it's a phone that I use for students. So this is your line to me. If you're out in the middle of the day, in the evening, can't do this at night, obviously, just call. Good morning or good afternoon, Dr. Padgett. I'm in your weather and climate class. I'm trying to get the app to work, or I have a question about contrails or whatever. It's best to you can ask questions even when you're out in the field. Let's see. So going to look at the temperatures. So it's not going to be too bad. The high today in Nashville is 45 degrees Fahrenheit. And then tomorrow, today. Oh, excuse me, I'm sorry. Today in Nashville, wow. It's not even going to get above 40 degrees Fahrenheit in Nashville today for the high. Then tomorrow it's 45. So yeah, it's going to be a little chilly when you're out there. If you want to do a cloud observations from inside where it's warm and look out of a window, even though technically that's not the proper way to do it, but be as comfortable as you can when you go out and do these observations, but you're really supposed to be outside. Also, again, one of the things that we're going to be doing is looking at not just your own naked eye observations of the atmospheric conditions, but we're going to look at observations in a couple of different locations. So if you go to the Weather Underground site, this is a site that has private weather stations. Some people have weather stations at the house. Tennessee State University has a weather station. For some reason, it's offline. I think it's because it's on the roof of Hale Hall. And maybe Hale Hall is powered down right now and they cut the power source. I don't know. So if I type in 37209, I get the Sylvan Park station, which is kind of close to TSU, but not really, but it's close enough. So this is not the, let me go right. This weather station is not the weather station that is the National Weather Service station. This is not the weather station that you would see on the news at night. This weather station, there it is in Sylvan Park. Could be it's on somebody's house, I don't know. And as you can see, it's pretty close to Tennessee State University. But as you can see on this map, there are many private weather stations. um, all over the city. And so once you find the weather station closest to your house, or at least approximately close to it, you can just get that link here. A lot of, and here's the link straight to it, hopefully without a whole lot of ads. And then you just paste that link to that weather station closest to you, and then make note of the temperature at around the same time that you make your observations. So when you go outside, make your observations, you should take a look at this weather station, and because you'll be asked to make a comparison. Now, on the other hand, there are National Weather Service weather stations. Now, these are the federal government's weather stations. These are the official weather stations that are used to report local temperatures to news stations. And so same thing, 37209, that's Tennessee State University's zip code area. Notice that the official station is the John C. Toon Airport. So that's like an official weather station. So that's one of the weather stations that would perhaps be used to report on the local news weather channel at night or in the morning or whenever. So just find that weather station and then take the link from there and then paste that right into this document here. So now you have links to the weather station in your neighborhood, and then there's the official weather station. When you go outside, wherever you go, get the latitude and longitude. You can either use, there are a couple of really neat apps that you can use to do that. Here is the Where I Am app. Tells you latitude and longitude in decimal degrees. Very simple. That's wherever your location is. So you'll do that whenever you go outside, get your location. Latitude and longitude. The latitude is in this case, is the N north, 36.049, so on and so forth. And then longitude is the number that in this case for us will be west longitude, west of the prime meridian. And notice that in the Western hemisphere, longitude is expressed as a negative number. So let's see if this was you. Let me just type in 36 point. Do not round these numbers off. Every number behind the decimal is important. Each degree of latitude is approximately 69 miles. And so each number behind the decimal represents a fraction of 69 miles. So we have tenths, hundredths, 10,000ths, 100,000ths, millions. So if you take so let's see. So there are 5,280 feet per mile times 69 miles per degree. And you divide that. So that's 364,320 feet. And we divide that by 1 million. Equals 0.36 feet, or about 4 inches. Okay. So don't round the numbers off, because each one of those numbers behind the decimal gives us a greater level of accuracy for our latitude, longitude, location. And I just showed you exactly why that is. This gets us down to about 4 inches of accuracy when we break that 69 miles into millions. So don't round the numbers off. Okay, so that's the first thing that you'll do is when you get outside is use your naked eye to make an observation. And then again, after you complete the data sheet, after you complete this cloud observation sheet, whether you do it in a PDF format or however you do it, save it, either scan it or take a clear photo of it and then upload it to the Dropbox. Also email it to me at tsuglobalme@gmail.com, or send it or text it to me as an attachment to 615-258-3657. But, well, you must upload it to the Dropbox. I would also like for you to do the other two also, so just so I'll have it. Make sure if you send it to me to identify yourself. So again, you'll do it with your naked eye. Then the second time that you make the observation, this is all at the same time. Naked eye first, app second. And you'll use the app. Just go through, the app will pretty much walk you through the instructions. It'll walk you through. You'll be prompted to add information into the app. I'm sure all of you have used apps before. You should be familiar with this. And you'll make a cloud observation at the same time that you did your naked eye observation. Now, the difference is that using the app is that a couple of days later, you'll get this satellite match. So what this is a NASA satellite hovering overhead will take a cloud observation at the same time and approximate location that you do. And as you can see by this result, they might not necessarily be the same. Notice here, the student definitely saw clouds. Saw high clouds, cirrus clouds, middle clouds, alto cumulus clouds. They saw low stratus clouds using with the app. However, the satellite saw no clouds. And again, as I mentioned on Tuesday, this hammers home the point that we still need human beings out in the field to make observations because satellites can't see everything. Now, the students saw a few clouds, but they were definitely there. Satellites saw no clouds. And in some cases, if the clouds are very, very high, or maybe we might not make the observations from the ground properly, the satellite can then give us a better idea of what the cloud height actually is. It's very difficult to estimate cloud height from the ground with the naked eye, or even with the app, because even though you're using the app to enter the data, you're still using the naked eye to make the observation. And then, so you'll get this in your email, this satellite match in your email a couple of days after you actually make your observation. Once you do that, upload it to the Dropbox. Also, forward the email that you get to me. So I'll have everybody's cloud observations. Then you have some essay questions to answer. And somebody asked, is this one essay or three? If I were you, I would just make these long answers so you can just type your answer to A right there. How do your cloud observations using the app compare to the satellite match that you got? So how do your observations compare to the satellite? Um, Again, when you look at the weather stations, is there a difference between your local weather station and the National Weather Service station with regard to temperature, cloud cover percentage, precipitation, and other pertinent weather observations? Is there a difference in any of these um, measurements? Perhaps there is, perhaps there's not. If you notice any significant differences, if so, what do you think influenced those differences? And you can have at it. We'll discuss it later. Did you see anything else interesting while you were outside? The answer to that cannot be no. You had to see something. You know, how often do we take the time to just look at the sky? And then what did you learn? What did you find most interesting? So again, each one of these you can just answer right here. And then upload this Word document and other required materials to the Dropbox before the posted deadline. Again, this is due at 9 a.m. on Saturday. And that is because what we'll be doing, let me go back to the course webpage, to the calendar. Week 1 schedule. So on Saturday morning, and I'll send you all the Zoom link. So the plan is for on Saturday morning from 9 a.m. to noon Eastern time, I'm going to be working with, or hopefully we are going to be working with students in the Detroit, Michigan area. They're middle school and high school students. And so they are participating in a weather and atmospheric science educational program. They're doing an exercise very similar to what you're doing. And all I'm asking is that, you know, you engage with these students. They want to be where you are right now. They're in high school, they're in middle school, these are urban inner city students. We're trying to get them to consider studying science, technology, engineering, and math. And we're doing that through exposing them to atmospheric science in Detroit. And so, like I said, just want you to engage, you know, so that they perhaps will aspire to be where you are right now. College student, maybe majoring in STEM, maybe not, but that's all we're asking you to do. You do not have to be present for the entire 3 hours. Just if you can show up for a portion, that's fine. And if you read the syllabus, I'm sure you did, you probably noticed in the syllabus that this exercise on Saturday is part of the service learning outreach activities that will be included in your grade at some, in one way, shape, or form. So hopefully you'll be able to make it for however much time on Saturday as a service to the community. And so Tennessee State University is a university that draws from a national audience. You know, there are students from all over the country. And so we can do a service to our community, in this case, science education for urban youth, through this course. And so I will send you all the Zoom link as soon as possible. You'll get it definitely before Saturday morning. And talk to the young people, you know, be a role model, you know, be an example. Like I said, ask them questions. The main thing I want you to do is ask them questions. You know, they're going to go outside. They're going to do the exact same experiment that you're doing. And I just want you to engage with the youth. Okay, so that's the task for this week. Does anybody have any questions at this time? Okay, so if there are no questions, I'm going to stop the recording.